All right. I actually think this will probably work. It's not the ideal audiovisual setup, but given the alternative right now, I think this will have to suffice for this live office hour and possibly tomorrow as well, depending on how well Xfinity is able to troubleshoot the problems. Um, Apologies for all the technical concerns earlier, and apologies to a few of you who apparently were able to hear me yelling at the Xfinity automated robot AI customer service infinite loop on the 15 going into 16th loop of the customer service um, access attempt. Anyway, apologies for that. But as you can see, I'm in a different place than usual. I'm currently in my office here at the National Center for Atmospheric Research. Of course, that's in Boulder, Colorado. And it's not a glamorous backdrop, but it seems that the internet is a lot more stable than in the home office right now. So we need to ask who the provider is in this building. Anyway, let's see. Well, I'm glad I'm able to speak with folks right now because there's actually quite a lot going on today, and there continues to be a lot to talk about. And this is the storm that won't quit in Southern California. Man, it is just keeping going. And it did finally make it all the way south to San Diego today. In fact, San Diego area has seen flash flood warnings and even a tornado warning so far today. So there has been some strong, heavy rainfall, strong thunderstorm activity, and then even a potentially tornadic thunderstorm. So let me actually just jump to the radar right away. I think that's probably the most interesting thing to take a look at right now. So I'm going to share that. It's a little bit more difficult for me to share than usual since I need to use a slightly different screen and monitor setup, but I should be able to make that work. Let's see. I need to change that. Good old radar scope. All right. Here we go. All right, momentarily you'll see radar on screen. You should see radar on screen. All right, hold on a moment, folks. Okay, there we go. I'm still getting used to this new setup. So let's dig into this. So the atmospheric river is, well, let me actually hop down to San Diego first, even though this is a very active radar screen. The atmospheric river is now officially moved on. It's gone. It's down. It's way down here in northern Baja, California. So the atmospheric river part of the storm has moved on. But down in San Diego, although San Diego proper is getting a break right now, you see these lines of thunderstorms now generating torrential downpours inland and upslope. But I'm going to go back to the radars a little farther to the north because once again, it's the LA area and Orange County that are getting really hard hit. And what I see right now is some of the heaviest rain earlier in the day in far eastern LA County, so sort of East LA, eastward, including most of Orange County, and then into portions. As you can see, it's actually, again, the radar artificially is cutting off the beam here because of topography. And again, here, all of that is artificially quiet. But what you can, because of the radar beam hitting the mountains, but you can see there's some very heavy rain that was earlier over Orange County that's moved now into the Inland Empire and into the San Gabriels. So this is now producing really heavy precipitation up in the mountains there. But the thing I actually really want to dig into now is a little bit farther to the north, right back over LA once again. And here we go. Oh man. Oh boy. Okay, the app has stalled again. I need to close it, reopen it, and reshare it. Sorry, I won't be able to zoom otherwise. Just need to share that one more time. Make sure that's still being shared. All right, now I just need to make sure this is syncing up correctly. Again, not quite used to this setup, but all right. So what is remarkable right now is that this this blob of now very heavy rain, once again, starting to move into the west side of LA County and over portions of Ventura County. This is not associated with the atmospheric river. This is mainly convective precipitation, meaning tall cumulus clouds and showers and thunderstorms. And they're actually, in this case, there is some cloud-to-ground lightning showing up in this band. This is moving over Malibu, or about to move over Malibu. This is going to cause big problems, and although it does not appear that there are currently any flash flood warnings in effect over the LA area, I think these are going to be reissued imminently by the Weather Service in Oxnard, because this band here looks like a problem for the southeastern part of Ventura County and up into Santa Clarita as this moves east. This band of extremely heavy rain is going to cause problems right along the Pacific Coast Highway and into the western Santa Monica Mountains as it moves eastward. So it's a little bit hard to predict exactly how much progress this is going to make as it moves eastward. But the real problem here is that the real problem here is that the soil is already saturated. We're already seeing almost continuous small to medium-sized mudslides in the transverse ranges, but especially, and this has really been the region that's been hardest hit, the Santa Monica Mountains. So we're really talking about this area all the way into including places like West Hollywood and above Malibu and Topanga Canyon, all the other canyons that mostly run towards the coast. In that fashion, this could be trouble if it makes it any farther to the north. In fact, it already looks like the rainfall in this region is intensifying. And then all of these individual cells up here, I don't know if they're producing lightning, but they're definitely producing very intense rain. So I mentioned how the city of LA, the county of LA, had, despite historic record-breaking rainfall, managed to weather the event relatively well so far without any catastrophic incidents, but that I hoped that there would not be any strong convective elements with extremely heavy precipitation following the historic moderate to heavy rainfall, but sustained over many hours in previous days. And unfortunately, this is exactly the kind of feature that I was talking about. So in this live stream, I'm going to start keeping a close eye on this as this moves to the east, and it actually looks like this could be a real mess for LA County if this holds together, or especially if it intensifies. So additional showers and thunderstorms developing all the way back in Ventura. Again, these are isolated, very intense convective showers and thunderstorms. Let's see if the Vandenberg site looks. Yeah, there's some lighter convective showers, but these aren't going to cause any problems. So really, at this point, the focus is almost exactly from Ventura County eastward in terms of remaining concern for significant flood risk. And it is because of this just incessant region of unceasing heavy rainfall that is now re-intensified, and where the hourly rainfall rates are potentially quite high. In fact, let me see if I can pull up the 1 hour accumulation product here. So this is radar imagery showing the 1 hour accumulation product, and I actually can't see the scale here. Apologies, I'm going to have to do some awkward okay, so if you can see, there's a small blue pixel right just on the Pacific Coast Highway just west of Malibu. That's corresponding to over a half inch per hour, and the gray, the dark gray, this broader region, corresponds to between 1/4 and 1/2 inch per hour. So we're starting to see rainfall of 1/4 to 1/2 inch per hour in this area, with pockets of 1/2 inch per hour or more. That is now heavy enough, given how conditions have been, to cause major problems. I'm actually just curious what the storm total accumulation looks like here. So this is over the course of the whole event. Now let me pause the loop at the end. These radar totals are not going to be accurate up in the transverse ranges because, as I mentioned, the radar beam is blocked, so it's actually a lot heavier than it looks. But if I use the inspection tool here, look at this. So that's underselling things a bit. So what it kind of looks like, actually, and this may not capture the whole rain event. That's part of the challenge. This is only showing about 5 inches in West LA, and we know that that part of the city has seen 10 to 12 inches. Even up here, it's not as high. So I'm guessing this is not capturing the whole event, or the radar is significantly underestimating the amount. Let's look at the echo top, see if there's anything interesting. Nothing too interesting there, so I'll just bring it back to ordinary rain rates. And given all of that, it sounds like, whoops, I just accidentally jumped to Colorado. Let me go back to Los Angeles, bring that back up. Here we go. Given this recent underestimate in the rainfall rates by radar, I wouldn't be too surprised if these pixels that are showing half inch per hour accumulations are actually higher. So again, watching this line of heavy showers and thunderstorms move eastward from right around Malibu and Topanga Canyon right now. Also, this line is intensifying. In fact, that's now got some really high reflectivity. This also appears to be moving over areas that could see significant flooding. So if this holds together, it's going to cause issues in an hour in the San Fernando Valley, where there is already rain, significant rain. I'm going to leave this up right now because it's actually a very dynamic and potentially high impact event right now, and I'm going to start taking a look at the questions. You have an opportunity. I think the earlier technical troubles scared away some viewers. So only 200 of you today. But so there's the ratio of comments to viewers can be a lot higher. We have more opportunities to chat with people. All right, let's see. Here's some comments. Peter Gordon remarked 6.8 inches of rain in Foothill Ranch on Sunday. Finally saw some blue sky, but now more rain. Aaron mentions the rainfall rates of 1.5 to 2 inches per hour early this morning in the Long Beach area, 0.3 inches in 10 minutes. Over 3.5 inches for today alone. That really is a remarkable amount of water, and probably resulted in some significant flash flooding, at least locally, I would imagine. That wouldn't be the first time that's happened, even in Long Beach specifically, over the past couple of weeks. So that's a considerable concern as this new band moves through yet again. Just continuing to glance at this radar. This is the kind of pattern I would not be surprised if the Pacific Coast Highway gets shut down by flooding or mudslides from this. So if it isn't already closed, Pacific Coast Highway, don't do it. Don't try it. Topanga Canyon is probably going to be a mess imminently, and we'll see what happens as these bands move further east. The big concern is going to be if this holds together into this sort of arc, this part of the Santa Monica Mountains, the more populated part of the Santa Monica Mountains, where there have been apparently around 150 small to medium-sized mudslides during this event so far, or debris flows collectively. This is going to trigger a bunch more if this holds together, which it looks like it might. All right. Oh, volume is way down. Thanks for letting me know. I can quickly check this out. I am on. Okay, I can see that happening. Cranking up the volume a little bit. If it gets too loud for you, you can always turn it down. But sometimes it doesn't work to go above max. I'm just using the native speakers microphone in the laptop itself as well as the camera. So let me know if that's better. I just adjusted the gain on the internal mic to make it easier to hear. Have to work with me. All right, so there's a question about what causes these narrow convective bands. So essentially, what we've got are right now. Well, let me actually, in this case, let me show some other things. So I'm going to zoom out a little bit. Let me go back down to the Santa Ana Mountains. I'm trying to show something, spatial feature. So you can kind of see this a little bit. Can you, for those of you watching, let me zoom in a little bit before I try drawing. There is a center, a small center of circulation, a weak mesolow, as you might call them, right in this region. This is not, the big scary low, the bomb cyclone from earlier in the event. This is just a weak little low pressure area. And right around it, you sort of have winds that are flowing. You have winds flowing like this around the small little cyclone. And this has almost got a little bit of an eye-like feature. There's some radar reflectivity ringing most of this little meso-low. We might be able to see that in satellite. I'll pull that up in a minute. But this is essentially means there's some positive vorticity advection. So there's movement of cyclonic atmospheric spin in the atmosphere upwind of the low. So in this case, this is the cyclone, or the little cyclone, and it's sort of moving in this direction. So it's transporting that spin in lower levels of the atmosphere into the region. That is partially contributing to the lift sort of up in this vicinity. So that's why we're seeing what we're seeing in this sector of this little meso-low right now. This is similar to some of the patterns we've seen recently that brought big-time localized flash flooding to Long Beach, to San Diego recently, and then earlier this season up in Ventura. So hopefully that the Santa Monica Malibu corridor isn't the next one here, but given what we're seeing on radar right now, I wouldn't rule it out. But more broadly speaking, so you have this little meso-low, it looks like, that's generating some localized lift in the atmosphere. You also have just an atmosphere that is generally unstable to perturbations anyway. So atmospheric instability refers to instability usually in a vertical sense, not in a horizontal sense. And so what that means is that if you give the atmosphere a kick, a little nudge, if there are thermals, for example, the ordinary thermals that birds of prey or hang gliders will ride, the reason for turbulence when you take off from LAX, for example. Those thermals, when the air is conditionally unstable like it is today, once they reach a certain altitude, it's essentially the atmospheric buoyancy profile is such that they actually continue to rise. So normally thermals are sort of self-limited. They might rise a few hundred feet. They kind of lose their oomph due to negative buoyancy and then sort of fall back to the surface. But in the case of unstable atmosphere, those initial perturbations, they actually start to become spontaneously positively buoyant as they rise past that certain level, especially once you get in a cloud, because the rate at which temperature decreases with height decreases. It becomes a shallower lapse rate, is the technical term, when you're in a cloud. So once that cloud develops, it actually then starts to become easier for that air to continue to rise and maintain that positive buoyancy. So we have an unstable atmosphere, we have a little bit of mesoscale lift, and we have, at least in the outside of the rain zone, we have plenty of sunshine. It's sunny over here, it's sunny over here. So there is enough thermal energy causing these thermals to rise into these puffy convective towers. We'll see how good my drawing skills are here. And you get these cumulus clouds and you get these cumulonimbus clouds that sort of glaciate out towards the top, and you get the rain here, and you have effectively an updrafts inside of these that become self-sustaining. So this area right here, right near Malibu, this is what you're seeing there right now. And so as these little thermals start to rise, normally they'd sort of start to fall back down, but then they continue to rise in an unstable atmosphere, and after a certain point, they actually shoot up all the way up to the level where the buoyancy goes away, and that usually they level out at the glaciated top of the cloud. This often, if you get a thunderstorm like this, this will represent the top of the troposphere. So you'll get up close to the in a stronger thunderstorm, this will sort of hit the ultimate inversion up at the tropopause. So I don't know. I don't think these are pretty low-topped storms right now. I don't think we're quite getting up that high. But the same process applies even if it's hitting some other stable air in the atmosphere that's not the tropopause. Just making sure that image actually showed up on screen, because there's a little bit of a mismatch between what I see, but I think it's working well enough. So just checking all the messages again. Hearing my phone ring, that may be Xfinity, but I thought we'd already set all that up. Unfortunately, I missed a couple other interviews today, but that's the way the cookie crumbles, I guess. All right, so right now there's just this big amorphous convective blob, and it is continuing its eastward progress into West LA, so we'll keep an eye on that. I'm going to share something different now. I'm going to share my I need to share a window. I'm going to share the satellite and radar. Okay. I see. For some reason, it's not sharing. Okay, let me just shift the window that it's sharing. Okay, you won't see the full window, but I think right now I'll just have to be careful with how I zoom. So really what you can see right now is this is that little mesolow that I was talking about. You see this spin in the atmosphere sort of right around the islands, the Catalina Islands here. This is what sort of is contributing to all of that convective stuff that's blowing up over Ventura and Los Angeles County. And look at what's going on down in Orange and San Diego counties. It's sunny right now along the coast. The atmospheric river has since moved on. But this big blob is going to have to go through LA County and Orange County and maybe San Diego County later. So San Diego County is not done yet. In fact, some of the heaviest hourly rainfall rates could be potentially even yet to come as these showers and thunderstorms continue to move through. But this is the big picture, and you can kind of see what I mean. There's some sun over the ocean, over the land here. Maybe not as much sun over here, but those are high, thin clouds, so there is some solar radiation getting to the surface, kickstarting those thermals, things like that. But what I would like to also share are some other things on here. I'm going to look at the power outage map in California. Let's see what you see on the screen. And obviously these numbers are well down from where they were before. I'd say only 127,000 customers out. So that still equates, though, to 300,000 or 400,000 people who remain without power. And for some people, this is now day 3 without electricity. And at this point, the hardest hit counties appear to be Sonoma and Mendocino County. So that's still a significant number of people out, but the utilities have made a lot of progress from the wind damage up north. So there are some people who are not expected to get their power back until the end of the week. That would probably be some of the more rural areas. So folks who are out in those areas, it might be a while yet. Apologies. Now Xfinity won't stop calling, of course, after refusing to reach out. I wonder if that social media pressure actually did anything in this case. Guess we'll see what messages they leave. Um, all right, I'm going to take another look at the questions here. Man, I'm not sure that I've ever had anybody that persistent. Um, Thanks for letting me know that there were audio issues. By the way, I don't always know. I don't have anybody helping me with tech setup, and believe it or not, I am not, an IT guru by any means. So the exception today is that I'm in a different place than usual because of tech issues. I mentioned this. I'm in my office at NCAR, so I'm not used to this setup. It actually seems to be working all right, but I'm not fully accustomed to all of the tweaks I need to make it maximally accessible for people. So apologies for any issues, but I'm glad that people can hear me better now. I'm going to, let's see. I'm going to bring up another map. This time you should see weather map. I'm going to try and recenter this again so that it's a little bit more clearer. This is the one thing that's kind of suboptimal with this setup, is that it doesn't show the whole screen, but I think you'll get the idea. But I need to go to something else. I would like to go to the European ensemble now. All right. So now that and I'm trying, actually, let me make sure that this is focused on the right part of the state. Well, I can't quite fit all of this in one. So let me perhaps zoom out, and then that will fit in the window better in this setting. Bear with me as I select the right region. That cuts off Northern California. So what if I do Western US? Where is that? Not quite where I would expect. Let me actually pop over to Tropical Tidbits. I think theirs is easier to navigate. Let's go to Western US. Let's look at the European Model Ensemble. And let's look at the... You know what? I'll look at the American Model Ensemble just because the most recent European Model Ensemble has not yet finished its update cycle. All right, that looks like a pretty good image. Everybody should be able to see that. Okay, so this is the reason I bring this up is, although California looks like it will dry out in relative terms, it's not going to be a completely dry pattern, and we may be entering another really active cycle by mid-February. So I do think we're going to get something of a break. This precipitation right now, you can see that blob of heavy rain continuing yet again across LA County tonight, but there will still be some additional heavy showers down into San Diego County overnight. In fact, potentially up to an additional inch or so across almost all of Southern California from LA County down to the northern part of Baja. So this is not quite over yet, and there could still be some significant flood issues this evening if those thunderstorm downpours move over already saturated mountain soils. But what I wanted to show is that moving into later this week, there'll be potentially another wave of precipitation. This would be Wednesday into Thursday. It doesn't look super heavy, but the 24-hour precipitation during that event could potentially be another quarter to half inch in Southern California, along with some decent accumulation in the Sierra Nevada. That would be a colder storm, so that's actually a quarter to half inch of liquid equivalent could meaningfully add to the snowpack. Hold on for just a minute. I have to answer this because otherwise I'm not sure Xfinity is ever going to fix our problem. Apologies for that. This has turned into a day where I am not really able to control the quality of these live streams very well, but I've asked apparently the corporate office at Xfinity is calling, so maybe something good will come of that. We'll see. I told them to call me back, by the way. So, all right. I just want to make sure that everything is still visible and connected. Yes. Okay, good. Just need to scroll back over to the right tab here. Sorry for all the clicking. This is not my usual setup here. Okay. I gave them half an hour. So things looks like there's going to be actually a pretty good dry break over the weekend. So later Saturday into Sunday, most or all of California should be dry. That'll be a good period for everyone to dry out, clean up, things like that. And that may continue into the early in the following week as well. So actually this dry period could extend through much of next week, in which case that's good news. I don't really think anybody in California needs more rain right now. So we'll take the reprieve, I think, as a win. But then there are pretty strong indications that once we get toward mid-February, and that's only about 10 days out, that a much wetter pattern will return. And at that point, it's difficult to you can't really pinpoint individual storms, but it looks like the potential for even some heavier precipitation again, once again by mid-February. Let's look at what the European ensemble says. We have to go back to an earlier version of this run, but it's singing a similar tune. And in particular, the European model is suggesting that Southern California could be one of the more hard-hit regions once again. It's not indicating anything nearly as extreme as what we're currently experiencing, and it does suggest we'll have a week of dry conditions in between, which is really going to make a big difference, by the way. But it's not like soils are going to completely dry out in a week in mid-February, and so things are still going to be unusually wet. Antecedent conditions will be wet, and so the threshold for creating flood and debris flow and mudslide-related problems during this next potential wave a week from now or more is still going to be elevated. Also, what this would essentially guarantee is that all of Southern California will end up with an exceptionally wet winter. If you add what we've just experienced, what we're experiencing tonight, with what is projected over the next couple of weeks, that pretty much tells the story for the whole winter, even if it didn't rain anymore after February 21st on this map. So the predictions of an unusually wet winter season, especially January through March, due to a strong east-based El Nino, those will end up materializing this year. I pretty much can confirm it at this point. Also, it continues to be, on average, warmer than average. So that piece of the seasonal prediction seems to be bearing out as well. And just to indicate, right now we're in a bit of a cooler pattern in California, not a cold one by any means, but cooler than it has been. And then the upcoming wetter pattern later in February, right now it actually looks like it'll be an even warmer pattern than we're currently experiencing. So that's what the European model suggests, looking at the American model suggesting something similar with a relatively warm series of systems. And just to see what that pattern might look like, let's just pull up for fun the North Pacific map and look at what the jet stream might be doing during that period. Well, here's what the jet stream has been doing recently. Here is this is going back in time to Saturday up to the present. You can see that bomb cyclone dropping down below 980 millibars just west of San Francisco, in that favorable region of that enhanced jet stream, dipping down way into the subtropics. It's not typical to see the jet stream down over the Hawaiian Islands and then coming back north into California, but that's exactly what we saw. With even a little bit of a split stream. This is the subpolar jet. It's actually quite weak, and then subtropical jet is actually stronger, and they may remerge a bit just near California. That's kind of unusual. Usually the subtropical branch of the jet is much weaker than the subpolar branch, but that is not necessarily the case right now. So essentially the models are suggesting a split flow pattern, really becoming essentially a subtropical dominated pattern once again, but look at what happens towards mid-February. Another major Pacific jet extension, a low latitude jet extension, and then it makes it to California in many of these model ensemble members. The signal gets vaguer because, of course, we're looking 2+ weeks out, and it's smoothed across many ensemble members. But what does the European model say in its most recent full update cycle? It says something similar. It says that this jet stream, and boy, is that at a southerly latitude. The jet maximum is in central to southern Baja California. So this is definitely a pattern that would favor, at least in the European model, Southern California more. And frankly, that's exactly what the El Nino like pattern would probably favor. So, and we look at the precipitable water anomaly, and we see again that Southern California ends up being right at the bullseye. So the storm is ongoing right now. It will wrap up tomorrow, and you will get about aside from some additional scattered heavy showers maybe on Wednesday into Thursday, you'll get a break for about a week. And then it might be off to the races yet again. But we will see. That's farther out. I need to do some other work at some point between now and then. Look at the questions again. I'm going to share radar scope again because it was actually quite active. You will see momentarily the pretty colors again. All right, so what we're looking at is the radar out of Los Angeles once again, and there just continues to be very heavy convective downpours. There is this line moving in right now, sort of through the Simi Valley towards Santa Clarita and the San Fernando Valley broadly. But of even more concern is this blob of moderate to very heavy rainfall sort of between Santa Monica, Topanga, and Malibu, this blob. This whole axis of the Santa Monica Mountains has been experiencing probably the biggest rain totals and the biggest flood and mudslide problems so far, and this really could trigger yet more. So I'm actually going to quick pop over to Twitter and see if there's any reports out of things happening right now in this region. The Weather Service, by the way, just extended the flood watch until 1 a.m. tonight, and I think that's largely for this big blob. So it's not necessarily over yet, although we're almost there. We're getting there, but there's going to be this big blob to get through still. And I'm just looking to see, not seeing anything too dramatic right this very second, but let's see here. All right. So the thing I'm going to do is I'm going to leave this radar up while I look at the questions that are streaming in once again. Okay. So Teresa asked about the long range. I was just talking about that. It looks like after break, active, especially in Southern California again. Questions about San Diego specifically. There's a pretty good chance that this heavy-duty convective activity makes it back south. So after some hours of sun later this afternoon, we'll see what happens after that. Oh yes, for those who have heard my phone ring during these live sessions, that is the beginning of the X-Files theme song. So it's very recognizable. So I'd be disappointed if folks hadn't pointed that out. Let's see. Yeah, Patty mentions that folks in Monterey I'm guessing that's Pacific Grove. Not expected to get power until February 8th. I'm not surprised. I will say that if it gives folks any hope, that I do know some people who had estimated power restoration a few days in the future, and they got it back today earlier than predicted. So perhaps that's a good corporate strategy to overpromise, or to under promise and over deliver, I guess. Although I'm sure that's not going to happen everywhere because there is genuinely extensive power pole damage. Juliet asks, is there any way for this event will continue after tonight? It will be winding down after tonight, although there will be some additional scattered showers into tomorrow across Southern California and a brief secondary wave of some showers, maybe even isolated thunderstorms again Wednesday into Thursday. But it is winding down. Not everyone's going to see rain from that second wave, but there will be at least some isolated flood issues conceivable just because everything is just about as sopping wet as it could possibly be in Ventura, LA, and Orange counties at this point. All right, so there's a few interesting questions I want to all address. There's a question about whether we had a quote-unquote sting jet, and what is that exactly? I actually am not 100% sure about whether we officially ended up seeing one or not, although I wouldn't be too surprised given the synoptic setup. This would have been back over the weekend when the extreme winds occurred in Northern California with some gusts recorded over 90 to 100 miles an hour, so this was no slouch of a storm. A sting jet can occur when, and I'm going to actually bring back my camera view so folks can see me speaking as I talk about this. Or maybe, let's see. Okay, there we go. A sting jet is essentially the part of a mid-latitude cyclone, and it doesn't always occur, so this is not a uniform feature. Regarding the propensity for the air on the backside of the circulation around a mid-latitude cyclone that's undergoing rapid strengthening can sometimes dip back down to the surface or near the surface on the backside of the circulation. So if you imagine a cyclone sort of as a rotating cylinder, obviously you have winds sort of at the lower level of the atmosphere, and then you also have winds at the upper level of the atmosphere. And sometimes what can happen is those winds at the upper level of the atmosphere can descend as they spiral down toward the surface on the back end of a cyclone. And of course, in the upper atmosphere, the winds are much stronger than at the surface. Think about, the jet stream regularly blows at 150 or 200 miles an hour. Those would be catastrophically damaging winds at the surface, but they're quite ordinary at jet stream level. Pretty much all jet aircraft fly through winds like that every time they go up in the air. So bringing air that is moving very fast at high elevations down to near the surface can actually cause really unusually extreme winds to extend almost all the way to or near the surface. And honestly, sting jets are not fully well understood. They're very unusual in this part of the world, as are true bomb cyclones. They were recognized more in Western Europe and the UK in particular. So the European, the UK Met Office is sort of an authority on sting jets because they affect the British Isles, Ireland, etc. That part of the world tends to see them, and sometimes they can result in a lot of damage in Western Europe when they occur, bringing extremely powerful winds down to the surface. That's happened a couple of times in the UK this year. But that may have been part of the reason why such strong winds made it all the way to the surface during this weekend's extreme wind event. And it's not entirely clear exactly what causes some rapidly developing storms to feature these so-called sting jets. So named because they almost look like a scorpion's tail, sort of at an angle. They're narrow and they're relatively long, this descent down from the top to near the surface. So another interesting terminology that I don't think I've used in a California weather context before. I'll have to check and see if that actually happened. I'm not even sure there is a fully formal and quantitative definition of it, so I'm not exactly sure what to check, but I'll talk to the folks at the Weather Service in San Francisco and see what they think. But in any case, it was an extreme wind event across Northern California, especially in the San Francisco Bay Area, really from San Luis Obispo coast north to the Mendocino coast, at least portions of it, and then inland across portions of the Central Valley. That's really the places that were so hard hit from those winds, and that's where the power outages peaked, and some of them remain today. All right. One thing I wanted to point out, there's been a lot of conversation about what it means to have a 1,000-year rainfall event. Because some folks are talking about how some of the rain accumulations on the west side of LA were quote unquote 1,000-year values. This is particularly true, interestingly, at UCLA campus. So I've been up to the roof where there's a rain gauge up there on the roof of the UCLA campus. I believe that is the official campus rain gauge. So it is technically above the buildings, which helps, although there is some wind interference. But anyway, it's close enough, and it's close enough to other observations that I don't really have any trouble believing it in this case. I think the 48-hour totals at that site are over 12 inches. So that would be a record-breaking 2-day rainfall total by a huge margin, actually. And some folks have suggested that the return interval on this is something like greater than 1,000 years, meaning that you'd only expect rainfall totals that extreme over a 2-day period every 1,000 years or so in that particular location, which is a very rough indication that this was an exceptional rainfall event in that part of the state, in that part of the city in particular. But I'm a bit of a skeptic in terms of how we define recurrence intervals for localized extreme downpours. I think it's unlikely that this event was actually something that would only occur once in 1,000 years. And this isn't, for a moment, setting aside climate change. I think this is probably true just absent climate change and just mathematically speaking. There's a certain element of to this, if you can think about, if you've ever had, if you've been with a young kid who said, has anybody ever said this exact sequence of words while standing on your left leg on this part of the crosswalk ever before? Probably not, right? If that particular combination of things probably has never occurred before in the known universe. But is that a very exceptional statement? I guess maybe this is a bit of a tortured analogy, but the recurrence interval, you can actually define it too narrowly. So has this specific location ever seen a rainfall exceeding this specific amount at this specific time scale in this specific number of years? If you narrow it too much, then the answer often becomes, well, it's a really extreme value because, the campus rain gauge has never seen anything like this before. But maybe, a rain gauge, if there had been one 4 or 5 miles down the road in West LA, it wouldn't have been so rare. Maybe it would have happened during a really big thunderstorm downpour at some other point. So this is not to cast doubt on the general notion this was an exceptionally rare, perhaps multi-centennial type return interval locally in LA, but I do not think it is accurate in any meaningful sense of the word to call this event overall a quote-unquote 1,000-year storm in Los Angeles. And all of the media headlines have run with it today, and I think that is fundamentally inaccurate, because it certainly isn't across other parts of the city. It certainly isn't a 1,000-year event in terms of the impacts of this storm. I mean, it completely mischaracterizes the nature of the impacts in the event itself. And I think the reason for this is twofold. One is it's the statistics. And when we have, at UCLA, there's about 90 years of data for rainfall, which is actually a pretty good record. Many places in the world, we don't even have 50 years of contiguous records. So how do we estimate the likelihood or the magnitude? How big an event do you have to get to see a 1,000-year event if we've only observed maybe a 1/10 of 1,000-year period? And that's being generous. That's assuming we had 100 years of data. So how do we actually know what the 1,000-year event should look like? Well, there's all sorts of statistical techniques using extreme value theory, things like that. And that can be helpful up to a point, right? But the problem is we're really extrapolating so far in the tail of a distribution that's poorly constrained that I am pretty skeptical when people say this was a 10,000-year rain event or even a 1,000-year rain event or frankly even a 500-year rain event, because I don't really think the extreme value statistics always do a good job telling us in information sparse environments what events far out in the statistical distribution and the tail of that distribution actually look like. And I say that partly because there's evidence that if we use process-based physical modeling, so for example, this is something that my colleagues and I have done to assess ArcStorm, is we look at thousands of replications of the same century, of different sequences of plausible weather that could have occurred during the 20th century. So we aren't limited just to the 100 years that we observed, but we re-observe those 100 years over and over again by adding some noise and say, okay, what are other plausible sequences of events that we could have observed over that 100-year period? And if we do that, we often find that the return intervals for what we actually observed are not nearly as rare as they could have been. So in other words, randomly, we got a bit lucky in the 20th century that we didn't see more extreme things, because even absent climate change, much more extreme events in the 20th century occurred more often than not than we actually saw. So the problem with this is probably a little bit complicated to get into for this conversation. But what I really want to emphasize is this. Los Angeles did not experience the ArcStorm this week. It did not experience, in any meaningful sense of the term, a 1,000-year storm, either in terms of rainfall on any widespread basis or certainly in terms of impacts. I don't even think this was a 50-year storm or a 30-year storm in terms of impacts. Locally, your mileage may vary, but LA is a big city, the county is diverse, and this was very far from a plausible worst-case scenario. ArcStorm, by the way, is only supposed to be something that would happen every few hundred years, that hypothetical scenario. And it is a lot bigger than the event that we've just witnessed or are still living through. So that's not to diminish the impacts, and there could still be some problems yet to come with this last final wave. But I do want to issue caution in interpreting this, in interpreting what a 1,000-year storm actually means, because almost everybody gets this wrong, including some scientists. And this is where there's a bit of a disagreement between folks who really like to use solely statistical methods and those of us who really prefer to temper those with physical-based models and large ensembles. And usually, almost always, in fact, systematically, we find that the real world is capable of throwing a much wider range, much more extreme events at us than traditional extreme value statistical methods might suggest. This is sort of a systematic problem, and it's something we can resolve partly through process-based modeling. And unfortunately, the way we measure extreme rainfall events and categorize them, the way that the NOAA Precipitation Atlas behaves, doesn't do that. It just looks at the sparse observational record, fits a very uncertain curve to it, and says, okay, well, this is what we think the 1,000-year rain event would be, even though we've only got 50 to 90 years of data for this location. And then on top of all of that, of course, is climate change. And whatever the 1,000-year event was 100 years ago, I guarantee you it is not that value today. It is smaller. So the likelihood of seeing what was once the 1,000-year event previously is now higher, maybe a lot higher than it was in relative terms. Because even if you make a 1,000-year event, the 500-year event or the 250-year event, it's still super rare, but it's 2 to 4 times more likely than it used to be. But it also means that the actual magnitude of what would realistically be a 1,000-year event today is a lot higher than it used to be. In fact, this effect is amplified the farther out in the tail you go. So I'm actually much more confident that today the 1,000-year event is much greater than the 1,000-year event would have been 50 to 100 years ago than I am in saying that the 5 or 10-year event is clearly greater than it was a century ago. And that's not because climate change doesn't affect both, of course, but it's because the relative signal, theoretically, from a physical process-based perspective, is much stronger, because you're very sensitive to very small shifts in magnitude once you're up there in that rarefied part of the tail. So that's a little bit more math than I was planning on getting into today, but I think it's an interesting question, and it's relevant in this context. A lot of folks claiming, this was a 1,000-year storm. I understand where that's coming from. I don't think these folks are wrong mathematically per se, but I do question the underlying premise and the context in which these numbers are being shared, because I think they can actually be quite misleading. If LA just weathered the 1,000-year flood event, storm event on a citywide basis with this little damage, that would be an astonishing accomplishment, if an implausibly astonishing accomplishment. And as much as I wish that we could share that success, that's not what actually just happened. So just for some perspective there. All right. James Norris remarks the specific value for the UCLA gauge that I was talking about, the 48-hour total, is 13 inches and 28 hundredths. That is just an unbelievable value. I mean, there's a lot of years where the campus rain gauge doesn't see that much water. So that is just a phenomenal 48-hour amount. And this hasn't been a super dry winter in LA to begin with. And as I mentioned, there might be another really wet cycle coming for Southern California in a week or so. So the seasonal totals in LA County and Ventura County are just going to be amazing this year. Yeah, Nathan Franklin mentions there's some parallels here about sort of parallel universe type arguments and radical ontological possibilities that you find in the study of the formal study of philosophy. And I think that's true. You'd be surprised how many climate modelers you can convince quite easily to start getting into the sort of the model version of the many worlds hypothesis. But it's actually really a transformative. So Clara Desser's work at NCAR, in fact, I just met with Clara here in Boulder last week, this notion that how do we know that what we've observed in the real world is actually the most likely version of what could have happened during that period. And that sounds like a very whoa man kind of philosophical debate, but it actually has really practical implications for comparing observed trends to climate model predictions. Because, for example, if what we observed in the real world was an unlikely iteration of what could have happened during that period, and it doesn't match climate model predictions, does that mean that the model is wrong? Because the model is telling you what the most likely outcome is. Or does it mean that we just got unlucky and the model is probably right in the long run, but the particular window in which we had to observe the processes it is trying to represent was unrepresentative of what could have happened during that period? Again, it's very wordy, it's a little bit tricky, a little bit mind-bending, but this actually has huge practical implications for modern climate science and is actually germane to a lot of media headlines that are out there today. So lots of interesting work in the scientific literature there. All right. Well, I think I'm done answering the questions, but I do want to bring up the radar one more time. See what's going on. Fortunately, I'm just showing you again this big convective blob. It doesn't appear to have further strengthened. In fact, the most intense downpour seemed to have weakened slightly. So notice this blob that was down by Malibu is, I wouldn't say it fell apart, but it's not as intense. There's still a whole lot of rain and still a whole lot of convection, but right now the strongest stuff looks like it's up in Simi Valley, which is not quite the region of maximum intensity. So there's some big, there's some cells up here. All of these are likely causing some roadway flooding, some small stream flooding, and maybe some more mudslides. But I think we're once again just threading that needle, and I think the likelihood of seeing widespread 1+ inch per hour rates out of this is not super high. But it is still moving, this vorticity maximum associated with the spin. You can still see the spin down here. This is all moving, going to move over LA. So, as we get closer to the evening commute in LA, it looks like it's going to be messy again. And to the extent that the commute in LA begins at like 2 p.m., well, here we are. So good luck out there. Stay safe. If you can avoid one more commute cycle, this is a good one. Things should be better in the morning. And I think that's all I've got for you right now. I gotta go try and take a call from hopefully the Xfinity corporate office and see what the heck they're gonna do about this. So with that, I think I'm gonna close. Thank everyone for joining me. And yeah, it'll be great to see folks later when the connection is fixed. It's helpful to know that this works as a backup. Not the best audiovisual setup, but it works I'm here and you're listening, and at least it hasn't been interrupted. So the audio quality might not be quite as good, the video quality might not be quite as good, but it's it's something. And then you get a tour of my office. That's not too exciting. So that's all she wrote. All right, folks. Thanks for joining. Sorry about all the tech troubles earlier. I may or may not have another live stream tomorrow, depending on how things go. I do have other work I have to do at some point. Apologies to anybody who's listening whose email I have not responded to in the last week. There are many of you. And the next session might be a storm wrap-up, or it might be a discussion of what's next, because there looks like there is more in the pipeline, and it is going to be it's turned into a very interesting winter once again in California. So Southern and Central California are now pretty much on track for back-to-back very wet winters, which has not happened in a long time. So that's a conversation for another day. All right, thank you.